A very good day to all professors. My name is Joel, and together with me are my teammates Anand and Liyun. We are from Group 11, and our presentation topic will be the impact and responses of noise pollution by airports. In our presentation content, we'll be firstly covering the research aim and objectives, followed by the significance of study, literature review, methodology, survey results and discussion, and ending the entire presentation with conclusion. For research aim and objectives, the aim of the study is to explore the impacts of noise pollution caused by airports and the effectiveness of the responses made. Singapore Changi Airport will be the main airport of study. Through the research, the team will determine if there is a need to better manage the aircraft noise for the local communities. In total, we have 5 different objectives for the study. Firstly, to study impacts that noise pollution has on the local community around the airport. Secondly, to investigate the current measures, standards, laws and guidelines present in airports around the world to manage aircraft noise for its respective local community. Thirdly, to investigate the measures implemented by Singapore Changi Airport to manage aircraft noise for its local community. Fourthly, to examine the effectiveness of the implemented measures by Singapore Changi Airport through the use of a survey. Lastly, recommend new measures that Singapore Changi Airport can introduce and implement to better manage aircraft noise for its local community. Next, I will be discussing on the significance of study. Due to geographical constraints and/or for quick and easy access, airports are now being located closer to residential areas. The noise produced by the aircraft is considered to be the most substantial cause of adverse community reaction. ICAO also expect it would remain as such in the majority of regions in the world for the years to come. Discovering the impacts and responses of noise pollution will create awareness among the relevant decision makers. This will educate essential personnel to understand the significance of constantly reviewing these seemingly menial issues. With the data that is to be collected from the residents of Singapore, we will analyze and review to see if certain measures in place have lacked effectiveness to address noise concerns and should be improved. This will benefit the community residing around the airport.
Moving on to the literature review, we will be covering on the noise pollution, specifically aircraft noise and its impacts. Noise is defined to be unpleasant or unwanted sound. Not all noise are considered as noise pollution. Only when it exceeds above 65 decibels. Noise becomes hazardous when it exceeds 75 decibels and painful when it's exceeding 120 decibels. Aircraft noise is noise produced by aircraft during its operation. The value and intensity varies with the type of aircraft and engines that's incorporated in its power plants. The ICAO Annex 16 Environmental Protection, Volume 1 contains the standard and recommended practices. It also specified the requirements to obtain mandatory aircraft noise certification. Next, I will be covering 4 negative impacts of aircraft noise. Firstly, health impacts. The World Health Organization Environmental Noise Guidelines for the European region has evidence to show that noise is one of the top environmental hazards to both mental and physical health. A few health impacts include sleep disturbance, hearing impairment, and cardiovascular risk. Aircraft noise has a negative effect on animals due to the panicking responses to the sudden noise prompting escape behaviors. Biologists mentioned the risk of animals falling, running into objects, or being trampled on when they are in panic state, especially for younger animals. There also has been accidental damage of eggs when panicking. Aircraft noise can create community annoyance. The members of the International Commission of Biological Effects of Noise collected data that showed that annoyance towards aircraft noise has been increasing over the years. Many airports also receive complaints as part of their community outreach and noise monitoring efforts. Aircraft noise is also known to have the largest impact on house prices as compared to road and railway noise. Studies have also shown that aircraft noise affects the children's cognition and learning. A study conducted by the Road Traffic and Aircraft Noise Exposure and Children's Cognition and Health analyzed that there is a strong correlation between aircraft noise and poor comprehension, reading, and memory. Airports implemented night curfews, and these night curfews have an economic impact on the country. This impact rise from the reduction in passenger traffic, revenue, employees, and more.
As for the methodology of the research, the team expected a majority of responses from Singapore, and therefore the focus was placed on Singapore. Additional responses gathered from outside Singapore will be used as added value responses for the qualitative analysis portion. For the quantitative analysis, we were unable to get the noise contour map of Singapore. Therefore, we devised two methods to segregate the data points. The first method would be to use a proxy airport. In this case, we used Boston Logan International Airport. During the 1970s, then Prime Minister Lee Kuan Yew was flying over Boston Logan and was inspired by the development of the airport as it was surrounded by water bodies, as seen in the image on the right. The northern and southern tips of two of Boston Logan's runways face the direction of the sea, allowing flight paths to be directed to the seas. With that inspiration, Singapore relocated its airport to Changi. Similar to Boston Logan, Changi Airport has its runways located near the sea, which allowed flight paths to be seaward, as seen in the image on the right. In addition to that, the runway headings of Changi Airport are similar to that of Boston Logan, with Boston Logan's being 220 degrees and Changi's being 200 degrees. With that, due to many similarities, we chose Boston Logan International Airport as a proxy airport to devise the noise contour maps for Changi. Using Google Maps and the distance measuring function, we used the biggest noise contour of 60 decibels in Boston Logan's noise contour map to devise the noise contour for Changi. The distance for the 60 decibels noise contour was measured and fitted around Changi. The image on the right shows the noise contour that was estimated for Changi. This is only an estimate using Boston Logan's noise contour map. Any responses from the survey that will be conducted that have residences that fall within the red circle will be considered near the airport, while the rest will be considered far from the airport. The second method would be to use the Master Plan of Singapore, available on the Urban Redevelopment Authority website. The grey portion in the east region is Changi Airport. To segregate the proximities of the respondents' residences, the east region is considered near the airport, the north and west region is considered very far from the airport, and the central and northeast region is considered a little far from the airport. Data points will be consolidated according to these three proximities.
The team has developed a qualitative and quantitative research question that revolve around the impact of noise pollution. The qualitative question asks how airports can better mitigate aircraft noise and its impact on the local community. It allows participants to share diverse perspectives and views on the topic. The quantitative question is, are the noise abatement measures taken by airports sufficient in reducing the impact of aircraft noise? It is designed to uncover the relationship between variables to meet the objectives. The team has formulated three hypotheses. The first hypothesis addressed the relationship between annoyance level caused by commercial aircraft noise and the proximity of residents to the airport. The second hypothesis uncovers the relationship between health implications and proximity of residents to the airport. The third hypothesis addressed the relationship between well-being and proximity of residents to the airport. The team has identified the independent and dependent variables. The independent variable is the proximity of residents to the airport. The dependent variable are categorized into three main topics. Firstly, annoyance caused by aircraft operations. We look into the annoyance at different phases of flight and their overall annoyance level. Secondly, health implications look into three main areas: hypertension, hearing impairment or loss, and heart failure. Thirdly, well-being looks into sleep disturbance, mood changes, increased fatigue, and decline in performance. To be able to answer the research objectives, the questionnaire will be divided into four parts, namely demographic profile, health implications, social implications, and responses of airports. Participants of the survey are asked to rate their annoyance level on a 5-point Likert scale, ranging from not at all to extremely annoyed. Open-ended questions are used for the respondents to express their feelings and experiences not listed in other parts of the survey. The survey was distributed through various social media platforms from various residential areas for sufficient sample size for the test and control group. Data collected was analyzed using the SPSS software platform to conduct a statistical regression analysis to determine if there's a relationship between the variables.
The hypotheses were to identify any significant relationship between the independent variable of proximity of the residents to the airport, as aircraft noise is heard louder when closer to the airport, and the dependent variables of health implications, well-being, and annoyance caused by aircraft noise. A survey was sent out as discussed by Lee in the previous slides, and the responses were analyzed. To ensure that the data is statistically viable, we calculated the minimum number of responses required. As seen in the formula, N represents the minimum number of responses required, Z represents the Z-score at 95% level of confidence, which was 1.96, U represents the proportion of population, and D represents the margin of error, in this case 5% or 0.05. As only people 18 years and above were allowed to do the survey, and our focus being in Singapore, we took the total number of people 18 years and above divided by the total population of Singapore to get the proportion of population. The minimum number of responses required to make the data statistically viable was 214. Thankfully, we managed to gather a total of 248 responses, of which 241 were from Singapore, 7 from other countries, and 1 that did not have a valid postal code. The 7 responses that were from outside Singapore will only be used for suggestions on how airports can better mitigate noise. They will not be used for the quantitative study. As stated in the methodology, we had 2 methods to identify what is near and far from the airport. To assess which method to use, we plotted the data points on the respective maps. Method 1 was rejected as no points fell within the noise contour, and this would not give any results for the analysis, as we require data points within and outside the noise contour. Method 2 was accepted as we had sufficient data points for regions that were near the airport, a little far away from the airport, and very far away from the airport. The yellow and red pins, which are the west and the north regions respectively, are very far away from the airport. The purple and blue pins, which are the central and northeast regions respectively, are a little far away from the airport. Finally, the east region, which are the green pins, are very near the airport. In order for regression to be used on SPSS, we needed to change the dependent and independent variables to numerals, as string is not allowed. This will also give a clearer representation for presentation. As such, for the regions, the areas that were deemed very far from the airport will be assigned 0, a little far away 1, and near the airport 2. As a Likert scale was used to measure annoyance levels, not at all was designated 1, slightly 2, moderately 3, very 4, and extremely 5. For other questions about well-being and health implications, yes was designated 1, no, not applicable, and not sure were designated 0. Let's move to the first hypothesis, where we study if there is a significant relationship present between the proximity of residents to the airport and annoyance level caused by commercial aircraft. We can see the different dependent variables that fall within the annoyance caused by commercial aircraft during the different aircraft operations, from on-ground to during flight and during different times of the day. When regression was conducted, the following analysis was retrieved. Let's focus on R-square, significant F, constant, and B1. R-square signifies the proportion of variability that is explained by the model. Simply put, it explains the percentage at which the dependent variables can be explained by the independent variable. A range of between 0.1% and 1% of annoyance can be explained by the proximity of residents to the airport. There is a low level of positive correlation as well. The significant F, also known here as sig F, is compared to the level of significance of 5% to identify if there is a significant relationship or not. Constant is the y-intercept, while B1 is the gradient of the line for regression. As all significant Fs are above the level of significance of 5% or 0.05, we generally fail to reject the null hypothesis. This means that there is no significant relationship between annoyance caused by commercial aircraft operations and proximity of residents to the airport. Now, for the second hypothesis, we want to study if there is a significant relationship between health implications due to aircraft noise, namely hypertension, hearing impairment or loss, and heart failure, and the independent variable of proximity of residents to the airport. The regression analysis did not yield any results for hypertension and heart failure because there were no data points for the yes response. All respondents answered no to these conditions that were caused by aircraft noise. However, there were both yes and no responses for hearing impairment or loss. As such, when comparing the significant F to the level of significance for hearing impairment or loss, the significant F is higher than the level of significance. Therefore, we fail to reject the null hypothesis, showing that there is no significant relationship. However, we are not able to make any conclusions for hypertension and heart failure, and we say that there is insufficient evidence. Finally, moving to the last hypothesis, we are testing if there is a significant relationship between well-being and proximity of residents to the airport. In specific, it would be sleep disturbance, mood changes, increased fatigue, and decline in performance. When regression analysis was conducted, it showed that there is a low positive correlation between the dependent variables and the independent variable, namely well-being and proximity of residents to the airport respectively. As for significant relationship, we can see that all significant Fs are higher than the level of significance of 0.05, showing that there is no significant relationship between well-being and proximity of residents to the airport. As such, we fail to reject the null hypothesis.
CAAS has imposed measures to ensure that noise pollution caused by the airport is well kept to a minimum in residential areas. Such measures include, but are not limited to, having subsonic jet possess a noise certificate unless otherwise exempted, meet noise standards of ICAO Annex 16, Volume 1, Chapter 3 or equivalent, altitude restrictions for airways near residential areas. Seats and starts are predetermined waypoints that are shown in charts for the pilot to depart and approach an airport. Part of Singapore Changi Airport noise abatement procedure is that the noise preferential routes are included in all its charts. Measures taken on departure to reduce noise are such as flying over water bodies, steeper climb profiles, altitude restrictions, and reduced thrust settings. For approach to Singapore Changi Airport, the waypoint look plotted in stars will ensure that the pilot keep their feet wet, referring to when the aircraft would fly over a body of water, reducing the noise pollution over residential areas. For runway restrictions, between 0-100 hours to 0-600 hours, runway 20 right will have departure restrictions. Arrivals on that runway would also not be allowed to exit either reverse thrust as the runway is located closest to the residential areas. Besides measures taken by CAAS, the Housing Development Board or HDB, a government organisation responsible for Singapore's public housing, has also continuously improved the soundproofing in its flats. Since November 2014, government residential developments will use dry wall systems for interior partitions, and they will be filled with sound insulation materials. However, despite all the measures taken, there are still reports of annoyance regarding aircraft noise from the residents, but not from commercial aircraft. Due to geographical limitations, it is very common for the Air Force in developed countries to face issues such as aircraft noise affecting residential areas. For Singapore, where land is not of abundance to the little red dot, the issue is supercharged as the air bases are in proximity to high-density residential areas. As the geographical land is small in size, the territorial airspace would also be limited. As seen in the picture, the red path shows the actual flight path, and the purple shows how Singapore does not have the privilege of territorial airspace for its military assets. Upon departure, military aircraft from Paya Lebar Air Base will only have seconds before they have to make a 180-degree left turn, or they will risk infringing into our neighbour's territorial airspace. The purple path shows as proof of how our military aircraft would not be able to make a left turn to gain altitude before flying over residential areas to reduce the noise pollution caused. As such, the problem has been highly impacted in the northeastern region, such as Punggol and Sengkang, where the estates lies directly under the flight path of the fighter jets. For recommendations, more could have been done to improve the noise insulation for HDB flats near the air bases. Such improvement includes using noise buffers like trees and shrubs to mitigate noise. A study done by Forest Research stated that these vegetations would be able to further reduce noise by up to 10 decibels and reduce the noise in human ears by 50%. These vegetation can then be planted near the source of noise or even at the top of HDB blocks to even lower the amount of noise pollution exposed by the residents.
Finally, to put the whole research and presentation into perspective and to conclude, the research that my team and I embarked on was to understand the impacts of noise caused by aircraft. Our literature review showed that there were significant relationships between aircraft noise, which can be heard closer to the airports, and the various health implications, well-being and annoyance levels. We identified 3 hypotheses to test if there really is a significant relationship between the independent variable of proximity of residents to the airport and the dependent variables of annoyance, well-being and health implications. Our survey gathered majority responses in Singapore, and with focus being in Singapore, our analysis showed that there is no significant relationship or insufficient evidence between proximity of residents to the airport and the dependent variables of annoyance levels, health implications and well-being. However, this analysis does not speak for the rest of the world, as Changi Airport has been designed and located with the idea of future expansion towards the sea and having high decibels of aircraft noise directed at the sea instead of the local community. Changi Airport's runways are surrounded by water bodies and have devised flight paths that minimize flying over residential estates to help reduce exposure to the local community. In addition, noise insulation material is used for housing buildings to help dampen the noise levels. To add on to these measures, we recommended to plant noise buffers where aircraft noise originate or can be heard to further dampen noise caused by aircraft. To further enhance and develop the research, further studies can include measuring annoyance caused by aircraft over a certain period of time, conducting comparative time series analysis of other airports, and also studying noise caused by military aircrafts and airports as well. And with that, we come to the end of our presentation and appreciate all your time and attention. Thank you.